Assalamualaikum warahmatullahi wabarakatuh. My name is Adzreen Nulsyazwan and my partner is Muhammad Afiq Bin Munir, and we will be doing the question 1, which is show how you create a graph and show the traversal of the graph using graph first search algorithm. Okay, so for our graph, and the vertex is 1829374 and the edges are 37, 39, 98, 74, 82, and 81. And this is its adjacency matrix. In order to fill this table, we will look if the two vertices, the two vertex are connected to each other with an edge. For example, 2 and 1 are connected to each other. 2 and 1 are connected to each other with a vertex. So we will put 1. And if it's not, if two vertices are not connected with each other, we will put the value 0. For example, 3 and 1 are not connected to each other. By an edge, so we will use the value 0 to fill in the blank. And this is the adjacency list where we put all of the vertices are here, and then we put its neighbor here. Okay. Next is we move on to the breadth search. The function of breadth search is we want to find whether there is a path from source to all of the verticals in the graph. And here is its coding if we want to do code, and it uses the concept of queue, which is the first in and first out concept, and it also uses the operation enqueue and also the queue. Okay, let us see. First, we must initialize q as 0 to start the BFS. And then we pick a source. For this, I will be picking 1. And then we dequeue 1, and then we put its unvisited neighbor, which is 8 and 2. And then in the visited table, we change for 1, 2, and also 8 to T, which is true from false, because at first we initialize all of this as false. And then next is we dequeue 8, and then we will enqueue its unvisited neighbor, which is 9, and then we will put the value T in 9 at the visited table. And then next is we dequeue 2, and then we put and then we enqueue its unvisited vertex, which is 3, and then we will put the value T at 3 in the visited table. After that, we will enqueue 9, and we will enqueue 9, and we will dequeue 9, and we will enqueue its child, its neighboring vertex. But however, as you can see, all of the neighbor for 9, all of its neighbor for 9 have already been visited, so we don't need to enqueue any value, and then we don't need to change anything at the visited table, because all of its neighbor have already been visited. And then next is we dequeue 3, and then we enqueue its unvisited neighbor, which is 7, and then we put the value true to 7 in the visited table form. After that, we dequeue 7, and then we enqueue 4, which is the unvisited unvisited neighbor for the vertex 7, and then we put the value T, which is 2, in 4 for the visited table. And after that, we enqueue 4, but there are no unvisited neighbor for the vertex 4. So we will dequeue 4, and then we will enqueue nothing. And then Q will again become empty, which means that the BFS has already been done. And as you can see from the BFS, all of the vertexes can be visited from a source. which is the source that I have picked is 1, which means that 2, 3, 4, 7, 8, and 9 can be visited from the source 1. That is the function of BST. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq, and I will continue the presentation. And for my part is the shortest part recording. BFS we saw only tell us whether the part exists from source S to source vertex V. It does not tell us the path. We need to modify the algorithm to record the path. How we can do that? We do not know which vertex lie on this path until we reach the V. So the solution is use an additional array pred, and that V means that vertex was visited from V. So BFS plus pathfinding. This is the coding that we will use to find the pathfinding. This is some example. This is our graph, and the queue is empty, and true false also empty, and the visited table all is false. This is our previous adjacent list. So we insert the node 1 to the queue, and then after that we dq1 and insert or enqueue the neighbor of 1, that is 8 and 2, and we mark visited table 8 to 1, 2 to 1. After that we dq 8 and we place all unvisited neighbor to 2, that is unvisited table is 3, 8 and 1 have been visited, and mark 3 to 2. After that we dq2 and then 397. We take unvisited neighbor from 3, that is 9 and 7. 2 has been visited, and then we mark 7 to 3 and then 9 to 3. After that we dq3 and then we check the neighbor. It is 9, the neighbor, all neighbor have been visited, and then we dq3, we get 4, 7 and 4, 7, the neighbor is 4, and then we only 4 unvisited neighbor. Then we go to the 4 and then we mark as 7. So we dq7 and no unvisited neighbor for the number 4, and then we dq number 4 and then the queue is empty. After that we can do the pred by trace backward to the report path. This is the backward path that we get from the node and the visited from. This is 1 is the head, and then 2 to 1, 2 to 1, 3 to 2, 3 to 2, 4 to 7, 4 to 7, 7 to 3, 7 to 3, 8 to 1, 8 to 1, 9 to 3, 9 to 3. And then we can use this algorithm to get the BFS 3. And this is how we record the shortest distance from the previous coding. And that's all for my presentation for our group. Thank you.